a significant fairing upgrade to go do that. So that's part of what we gave the objectives to Lockheed. They did a search of the potential capabilities of the launch vehicle. So it came down to Delta V and minimizing modifications to both Orion and the launch vehicle.
Let's see, when will we be able to send humans to Mars, and when will we be able to send a human to Jupiter, or presumably around Jupiter?
You want to start?
Well, so first things first, we got to get humans back beyond low Earth orbit, and that's what we're trying to do with Orion as soon as we can. And then I think the key will be what is the next destination, and how do we get the systems, both technology and funding-wise, to make that happen. So right now there is no specific date for Mars. I think the key thing is to be pushing the envelope, learning more about extended duration, the kind of things that Rex talked about, so that we get those behind us, and so we can move forward onto the Mars trip.
Yeah, and I think this is a methodical program that we're going through. This is just the very first launch, but the important thing, this is Orion 001. If we have the opportunity to look back in the future about where this program went, there's no fixed assets that we're going to lose, like the space shuttle. The space shuttle, eventually we reused them until we could continue using them, but they would eventually reach the end of their lifetime. And the other thing about the space shuttle program is that it eventually you can fly it. We could have flown it for 10 more years potentially, but we're never going to leave low Earth orbit with it. So with this vehicle, we can go any of these places if we just do a build-up approach, and we can make it to Mars someday. It may take, we're not sure, but hopefully we can be in the Mars vicinity in the 2030s. So I think that is a reasonably attainable goal, but it's going to be a stair-step, slow fashion. It's not going to be easy. It's going to be something we just have to remain committed to, and if we remain committed to as a nation, as a space agency, as a contractor family, I think we can do it.
I think the long-term evolvable approach to SLS in general allows us that. We start with an early capability, a 70 metric ton capability, with the goal driving toward 130 metric tons. Taking that evolvable approach will allow us to prove the technologies that we develop new for this. It'll allow us to take incremental steps, going to the moon first, then maybe to an asteroid or toward Mars. So I think the evolvability is the real key.
Hey, an engineering question. I think you categorized this from Twitter, and it's a doozy. Is there any practical way to generate artificial gravity on a spaceship or colony?
Well, the only way to do it is to have a spacecraft that is tethered and that rotates, basically. So if you had two spacecraft with a long enough tether, you could rotate them on the way to Mars, and you'd have artificial gravity. The only problem is if it's got to be very, very large, because it can be very disoriented if you have a large spin rate. So it is possible. That'd be one way to counteract the zero-G in transit. But I think we're getting pretty good in the space station to find out ways to combat the atrophy you get from zero gravity by using exercise and countermeasures. So I think that won't be necessary, but it is possible it'd be very difficult.
This is an interesting question from Twitter. And maybe Rex can take the first crack at it. What qualities would you look for in the astronauts who will fly on Orion? And would an Olympian astrophysicist even make the cut?
An Olympian astrophysicist? Well, yeah, they might. There's a certain baseline technical expertise people need. And there's a lot of people that have that. But then the most important thing is the ability to get along with others and the ability to handle adversity. Even today with our 6-month missions to the space station, we train our astronauts to how to cope with adversity. We train them to develop their coping skills. How do you cope with things when they go wrong? We do things like sending people out into the wilderness for 10-day National Outdoor Leadership School training sessions where we learn about what are these people, how do they react when they're cold and wet and hungry. And you'd be surprised that when you get in those situations, you can learn to develop those coping skills. So we need somebody who has coping skills, because like I said, it's gonna be a tremendous journey to go someplace like Mars. So you need the coping skills, you need the interpersonal relationship skills, somebody who gets along well with just about everybody. And then somebody who has an incredible psychological fortitude to handle something like that, to leave his whole world behind and go someplace new with the hope of making new explorations and not a complete guarantee of ever getting back.
How long, this is from Twitter, how long will final assembly take on the EFT-1 Orion capsule, the one behind us?
What you see here is the primary structure that'll hold the pressure, for example, when we eventually send people out into space. That primary structure took us a few months to put together, but there are a lot of other pieces that are already in production that'll start showing up here at the Cape. So I think the next couple of key things to think about is all the the computers, the cables, all that kind of stuff will start showing up. We'll actually power it on in the February, March timeframe here, right here in this building, do the integrated testing then. The heat shield shows up a little bit later than that. So by the end of 2013, it'll be totally assembled and ready to be shipped for the launch.
Okay, we have just less than 10 minutes, so keep the great questions coming. Again, if you're on Twitter, hashtag AskNASA, and if you're on Google Plus or Facebook, just find the comment thread and put your question there, and we'll get to as many as we can before we have to end. Next question looks like it's from Facebook. How many test articles have been constructed and used so far?
Start with the Orion side, and then I know David's got stuff, and Pepper does too. So for Orion, we had Padabort 1, which was where we tested out the launch abort system. That was probably the first big test article that had to match the mass properties pretty close of what Orion would look like, because we did a full abort test using the full abort motor and attitude control motor. So that was the big one. We did a ground test article, which is actually also in this building, just a little bit down the way. Did that one, first of all, to get our manufacturing processes figured out, and then we also did a lot of acoustic testing, because during liftoff, the rocket creates a lot of sound energy, as well as if we did an abort, there's a lot of energy from that as well. So you need to test the structure under acoustic load and actually do vibration testing to see how it behaves. So we built a ground test article for that. We've done a few boilerplates, which are basically simple structures that model Orion, that we've dropped at Langley in the pool there to get to calibrate our models. As far as we've had a lot of then component test articles, like panels of the structure that we've put under load, all sorts of smaller pieces that we've done that to, down to Triple parts that we've tested. So I think if you're talking about the big ones, those are the big ones today. EFT1's the next one. Of course, you see it behind us. We'll reuse this structure, actually reuse the systems in it to do an ascent abort. Again, like I said, here out of the Cape, we'll put a Peacekeeper first stage underneath it and go do that test here out of Florida. So that's, and then we're on to EM1, which is in 2017.
From an SLS perspective, there's a lot of test articles we've had so far. You look at just in the J2X development, all of the motors that have been tested, the engines that have been tested down at Stennis. There's been, from a solid standpoint, there's been 3 development motors. Then if you start looking toward our support for EFT1, we're in the process now of assembling our first test article, which is our Pathfinder article at Marshall Space Flight Center. And then in the near term, we'll be building a structural test article also. As we get into further development from a core vehicle standpoint, we'll have significant test articles with that too. So from an overall SLS standpoint, it's been a significant amount of test articles in support of where we are.
And from a ground perspective, we largely benefit from the flight guys' test articles themselves. So we'll take a boilerplate that Mark developed, and then we'll run our recovery operations tests for his recovery operations that we'll perform. So we get benefit when the SLS guys are building their assets. We take our teams and go out to the respective test sites where they have their test articles at play. So we understand the functionality of the systems and can bring that to bear when we design our systems. So.
The test article we have at JSC, where we actually outfit it with the seats and the other systems inside, so we make sure that the crew functions can be done, the crew can put their suits on and off, they can get out in emergency. So that's another test article that has more to do with human factors assessments.
And I've been waiting for this question. I've seen it asked a few different ways, but it's the Beatles or Stones, right? It's why have we returned to a capsule design and not a wing design? What is it about capsule that makes it the right design for deep space moving forward?
Yeah, it really comes down to, again, that entry velocity. For us, a winged vehicle can make a lot more sense in low Earth orbit. You're using it to give you more flexibility on where you can land on the Earth's surface. We can get that coming back from the moon. The guidance and navigation algorithms and techniques nowadays are much better. We actually do a skip entry technique that slows us down and allows us to target very closely where we want to go. And a wing system would be much more difficult to implement in the high velocities, and it really would not add any functionality to our system that we need.
What and I think I'd ask you of maybe even the whole, all the panelists, what criteria would you find the EFT-1 mission deemed as successful? Successful. What are the success criteria for all of you?
We have a long list of specific data we're looking for on this test. Fundamentally, we're testing the heat shield, so that's the obvious one, and we're actually instrumenting it with hundreds of sensors, which allow us to validate our models that we've done to design the system. So we'll actually get real data that says, look, the heat shield performed as expected, and the environment was what we expected. So that's a big one. We do a lot of the other key things we're going to test is the guidance and navigation system I mentioned. We're actually going to take control of the capsule. It has to control its attitude during entry to make sure we hit the target point. So that's a key one. Did the GNC system work as planned? We have a lot of separation events. For example, the service module fairings will be jettisoned. The launch abort system will be jettisoned. The crew module is separated from the service module. These are all critical separation events that, again, we model very well. We have tools for. We're going to do some tests on the ground. But you really want to fly it in the flight environment to see that it works because they're very important to the system. And then we'll do the parachute deployment. Again, we do a lot of drop tests out in California, but we want to do the parachute deploy in the exact environments and the ranges we're going to see on flight. So I would say those are the key objectives. So a lot of stuff. There's a lot of stuff packed into this one flight.
I see only 2 minutes left, so I'm going to have to make... Please.
We're also, as David said, we're working out our interfaces with SLS. So we're going to understand the loads to the upper stage. That's important. And Pepper's guys are actually going to recover the capsule on the West Coast with their nominal plan. So they're going to be exercising those things as well. Those are all key objectives to the flight.
Okay, we're going to do speed round here. There's some really great questions. I want to get to as many as we can. Probably have time for like 2 more. The Orion capsule was built to explore. However, I'm a bit confused as to what capabilities will be without a landing module. Let's speak to that.
Yeah, the Orion is not by itself designed to land on another terrestrial body. It's the part that gets the crew there safely and gets them home. If you actually want to land on another body, you would need a lander. So that's part of an architecture that would have to be developed. So that's not the part of the mission that Orion performs.
Okay. Why is it called Orion? Any special meaning behind the mission name?
Gosh, I'm trying to remember. It's been so long ago we came up with that name. I think fundamentally because it's a part of human history to look to the stars. The Orion constellation is a big part of what people have seen for a long time, and I think correlate with space and our curiosity about what's out there. So,
okay. Unfortunately, I think that's going to have to do it for today. Thank you all for your time and for participating in this, and thank you all for joining us. If we didn't get to your question, fear not. We'll get to as many as we can on Twitter, Facebook, and Google+. We'll try to answer them over the next couple of days before the holiday. If we still don't get to it, just keep hammering us on Twitter. We try to do as the best job we can to answer all questions that come into us. A reminder, you can find all of NASA's social media accounts, including our various centers, missions, spacecraft, hardware, the tweeting robots, the folks tweeting from space, all of it at www.nasa.gov/connect. For more information about progress being made on the future of American human spaceflight, including Orion, the EFT-1 launch in 2014, the Space Launch System in development, the ground systems development and operations, and the thriving commercial space industry that's enabling NASA to set our sights in deep space destinations, you can visit us on the web at www.nasa.gov/exploration. That'll do it. So goodbye from the Kennedy Space Center, and thanks for being a part of the journey.